All right, hi, I'm back. Yeah, I don't think I can upload files of a certain size, so I needed that to be a little smaller rather than put the two together. So we're on page 4, and this was the last one that was on our schedule to be covered today. So this looks a little different from the ones we did before, but I'm going to start out doing the same thing I've been doing, and I'm going to factor that numerator, so that'll be x, what, minus 6, x plus 1, all right? And again, I don't see any of those two factors canceling with the denominator, so there are no wholes, all right? None of those. So it looks like we have a break in our domain at 2, so negative infinity to 2, and then 2 to infinity. That will also determine our vertical asymptote, and that'll occur where x equals 2. So that's going on the graph. Quick as a wink, x equals 2. Make sure you label things. Okay, now what else do we seem to be needing here? When your numerator degree is higher than your denominator degree, if you look back on your instruction sheet, that tells you that there is no horizontal asymptote, so none. In earlier grades, we'd be like, yay, and we wouldn't have to graph it. But here we also have to look for an oblique asymptote. And the way that you find that is you take your denominator and divide it into your numerator. So I'm going to do that over here. X minus 2 divided into x squared minus 5x minus 6. And you only have to do this until just before you get a remainder. You just need it to fill up all of the places in the top part of this symbol. So anyway, this will be an x. So x squared minus 2x, right? Change the signs. That's negative 3x minus 6. So the next thing you need up there is a negative 3, and that's it. You don't need to go any further. Y equals x minus 3. Okay? And we can put that in there. So that'll be 3 down, and then just a slope of 1. So like so. And down like so. And this is y equals x minus 3. Okay? So we're in pretty good shape here. So let's start out with your intercepts. Y-intercept. If you let all of these x's up here equal 0, then you get y equals negative 6 over negative 2, which is 3. So you have a, let's see, you have a an intersect point at 0, 3. Okay, so we'll mark that. And that actually determines that the branch kind of goes up at the top rather than down here. So it's either here or where I put the other question mark. It looks like it's going to be in the top part, not the bottom part. Okay? And so 0, 3, and the numerator, this and this are going to create our x-intercepts. So your x-intercepts are going to be 6, 0, and negative 1, 0. All right? So those are your x-intercepts. And so you're going to have one here, and you're going to have 1, 1, 2, 3, 4, 5, 6 here. All right? So pretty much we know where those branches are going to go. But let's just check to see if we intersect the oblique asymptote. And yes, you do have to check that. And I'm going to change this to OA from HA. And I'm going to do my work here. So I'm going to set the equation of my oblique asymptote. It's actually the expression x minus 3. And I'm going to set it equal to the expression of my function x squared minus 5x minus 6 over x minus 2. All right, so I'm going to multiply each side by x minus 2. All right, that cancels out. So I'm going to get x squared minus 5x plus 6 equals x squared minus 5x minus 6. Okay, those things don't equal, because if I subtract those out and add those out, I get 6 equals negative 6, which is a no, right? My writing is going downhill. So I'm going to get 6 equals negative 6, question mark, which is no. So that means we got lucky, and it does not intersect our oblique asymptote. So that's going to make graphing it easier. All right? So I'm just going to clean this out. I don't have the kind of room I would normally have if I was writing with a pencil. But I did a couple of extra points. I kind of didn't need them, but I just did it anyway. So negative 3, I used that, and I got negative 3.6. So negative 1, 2, 3, 1, 2, 3.6 was roughly here. And you can see the branch is forming pretty nicely. And it may not hug those asymptotes real closely, but eventually, if I could extend the graph, it would. And so over here, I did a 5 input, and I output a negative 2, so that's going to be here. And I could get more points, but, you know, we just need to get the overall appearance of what we're supposed to get. We don't have to go too crazy. So, look good? So we did not have anything here, and we did not have anything here in those two little triangular regions, which was kind of neat. Sometimes you do, but not here. All right, end behavior. So as x is going this way, y is going up, right? So f of x approaches infinity as x approaches infinity. All right, then we want to see what it's doing going the other way. All right, as x is going to the left, y is going down. So f of x approaches negative infinity as x approaches negative infinity. All right, so end behavior, pretty good. No worries there. All right, so looking at this, if I want to set up my, my sign analysis, I have a 0 right here. So negative infinity to there. I have a vertical asymptote here, and I have another 0 here. All right? So this is how it's going to look like when you assign your intervals. Hang on, I'm going to undo. Okay, let's see if I can get that back. Okay. Yeah, by question mark. All right, so we had negative infinity to negative 1. We had negative 1 to 2. We had 2 to 6. And we had 6 to infinity. All right? The intervals that we had, the first two came from the numerator. So x minus 6, parentheses are optional, x plus 1. Both of those went together in the numerator, and your denominator was x minus 2. And that created your function. Okay? So for starters, I'm going to check negative 2. If I put a negative 2 and subtract 6, I'm going to get something negative. If I put it in with x plus 1, I'm going to get something negative. But remember, those two multiply together in your numerator to make a plus. If I put it into x minus 2, I get another negative. That's a positive over a negative, which is a negative. The first, going left to right, should be below below 0, below the x-axis. All right, then here, I'm going to put in a 0. So 0 minus 6 is negative 6. That's negative. 0 plus 1 is 1. That's positive. 0, and by the way, these go together to make a negative. And then 0 minus 2 is negative, so negative over negative is a positive. This is above. And then I'm going to put in a 3. So 3 minus 6 is negative. 3 plus 1 is positive. Those two things go to negative. 3 minus 2 is positive. Negative over positive is negative. That's below. And then I'm going to put in a 7. Because if you put in a 6, like if you put in a 6 right here, you just get a 0, and 0 isn't positive or negative. So I don't need the numbers that define the interval. I need some of the ones that are in the interval. All right. So this is going to be plus. Next one is plus. Next one is plus. Overall it's plus. This is above. So we had below, above, below, above. Let's check that. Below, above, below, and above. It's a thing of beauty, right? So there it is. The assignment is worksheet B. You're going to have to dig into your packet to locate it because of the repeated pages. Go figure where those come from. And you do 1 through 5. You don't want to do more than that because it's a time-consuming process. And again, for doing your extra points, a calculator and store comes in really handy. So I will see you Monday. It's been my great pleasure. I hope your weekend is going swimmingly, and I will see you soon. Bye.